Hey everyone, welcome back to this Python series. My name is Ansh Patania and today we are going to learn a concept of Python file handling. So without wasting any time, let's get started. Before we write a single line of code, let's start from the absolute basic. Why do we need files in programming? Whenever you write a Python program and declare variable like this, let me give an example. Username is equals to Rahul, age is equals to 22, marks is equals to 90, 85, 95. Now, whenever you write a Python program and declare variables like this, where do these variables actually live while your script is running? They live inside your computer's RAM, random access memory. RAM is super fast, but it has one major limitation. It is volatile. Volatile means the moment you turn off your laptop, close your IDE, or run a new script, everything in RAM is wiped out completely. To understand memory, think of a RAM like a classroom whiteboard. During class, your teacher writes equation on it. It's super fast to write on and erase. But at the end of the day, the janitor wipes the whiteboard completely clean. Hard disk, SSD, storage is like a student's notebook. Writing in a notebook takes a little more effort than writing on a whiteboard. But tomorrow morning, when you open your notebook, your notes are still there. File handling in Python is simply the skill of taking data from our temporary whiteboard, which is RAM, and saving it into our permanent notebook, which is hard drive. Now, in computer systems, file broadly falls into two main categories: text files and binary files. So in text files, for example, .txt, you can use .txt, .csv, .json, .py, .html. These are stored as a sequence of human readable characters like letters, numbers, symbols. You can open them in Notepad and read them directly. And on the other side, binary files, png, .jpg, .mp4, .pdf, .exe, stored as raw bytes, zeros and ones. If you open a .png image in a notepad, you will see gibberish symbols like FF, D8, FF, E0. In this lecture, we will focus on text files which are used everywhere in software engineering, from reading configuration files to saving server logs. Now, when opening a file, Python needs to know where the file lives on your system. There are two ways to specify a file path. First is relative path, which is location relative to where your Python script is sitting. For example, sample.txt or data.txt or sample.txt. Now, our second method is absolute path, the full path starting from your system's root dictionary. For example, c:user /rahul /document /sample.txt on Windows, or /user rahul document sample.txt on Mac /Linux. So best practice is always try to use relative path so your computer code runs smoothly on anyone else's computer. Now, to work with a file in Python, we always follow a standard 3-step life cycle. First, open the file using the open built-in function. Second one is process the file, read or write. And the last one is close the file using .close built-in function to free up the memory resource. Let's understand this with an example. F is equals to open. Sample.txt, R. Data is equals to f.read print data f dot close. Now here I have performed 3 steps. First step is here, f is equals to open. In the first step we are opening the file in read mode. Our second step is to read the content, and our last step is to close the file. Now here f is the variable which is this variable is called a file object or file handle. It acts as a bridge between Python and the physical file on your hard drive. And the open, wait a minute guys, there is a mistake. And the open, it is a built-in Python function that takes 2 primary arguments. Argument 1 is sample.txt, which stores the name or path of file you want to access. Second argument is the character R. The mode R stands for read mode. It stands for read mode. We have to read the file, which is also called default mode. And next, f.read. It reads the entire text content of the file and return it as a single string. And at last, we have close.close. It closes the file connection. If you don't close files, you risk locking the file or leaking system resources. Now let's intentionally break Python right now. What happens if I try to open a file that doesn't exist yet? Let's understand this. Does not exist. Just.txt. Now let's run the code. Now as you can see, Python crashes with a file not found error. No such file or dictionary does not exist.txt. Now here, whenever you open a file in read mode, the file must already existed on your disk or Python will crash. Let's intentionally break Python right now. What happens if I try to open a file that doesn't exist yet? Now let's run a strange experiment. What happens if I call f.read twice in the same script? So this is the example. My compiler is not working for this topic file handling, so I'll explain this topic on the PPT. I will try to explain on the PPT. So this is the code right here. This is the code, and now let's understand the code. Why did the second print data display nothing at all? If you run this code, the second data will not print anything. It will print nothing. The cursor will end. And why? Now imagine reading a physical book with a bookmark. When you open the file and call f.read, Python starts reading from character 0 all the way to the end of the file. As it reads, an invisible file cursor moves along. By the time data 1 is finished, the cursor is sitting at the very end of the file when you call f.read. A second time, Python looks past the cursor and says there are no characters left to read, so it returns an empty string. Now, what if your file is 10 gigabytes in size? If you use f.read, Python will attempt to load all 10 GB into your RAM at once and crash your system. To prevent this, Python gives us two alternative methods. f.readLine, which reads one single line at a time, and the second method is f.readLines, reads all lines and return them as a Python list of string. Yep, as you can see in the 7th slide. Now this is the example for f.read, f.line and f.readlines. f.read will read the entire file. f.readline will read only one line, and f.readlines will read into list. So now let's move on to the next slide, writing and appending data. Now that we know how to read data, how do we write data into a file? Python provides two main modes for writing. W, this side, this W, for overwrite mode. It's also called write mode only. And A is for append mode. Now let's understand what is write mode. It creates a new file if it doesn't exist and completely overwrites the file if it already exists. And the second method, the append method. The append method creates a new file if it doesn't exist, or adds new text at the very end without deleting existing content. These are the examples. This is the example for the overwrite mode, and this is for the append mode. You can do this on your compiler. Here there's an important note. f.write does not add any line breaks automatically, and explicitly append a next line to force a new line. This /n means a new line. These two are the examples, and f.write writes the specified string into the file. And note that f.write does not automatically add a new line. I told you this. Here it is. And now let's pay a close attention on the W mode. The W mode is one of the most dangerous mode for beginners. If you open an existing file containing 10,000 liters of user database record in W mode, Python instantly truncate, which is also mean erase the entire file. It will erase the entire file to 0 bytes before you even write anything. Now here comes the rule of thumb. If you want to modify or add an existing file without destroying its current data, always use A mode, which is called append mode. Now, what if you want to perform both reading and writing operations using a single file handle? Python provides plus mode. R plus, wait, let me check if I have a slide. Yeah, as you can see, R plus is for the read plus write, and the starting cursor position is 0, and it will overwrite character by character. And the next mode is W plus. The primary function is read plus write, the same as R, but the starting cursor starts from beginning 0, and yes, it will wipes entire file first and then it will work. And at last we have append plus a plus, which the primary function is read plus write, and the cursor starts from the end of the file, and the truncate is not allowed. It all new appends all new writes. Here is an example of r plus mode. Now in professional software development, manually calling f.close is considered bad practice. Why? Because if your program encounters an error or crashes on line 5 before reaching line 10, where f.close is written, the file remains open in memory. To solve this, Python introduced the with syntax, also known as context manager. This is the traditional way, which is risky. F is equals to open, and if an error happens here, f.close will never run. This is the modern way, Pythonic way, which is safe, and it will automatically close here if error occurs. Now let's understand the use of with here. With means it is a keyword in Python that starts a context manager block. The open.sample text opens the file connection as usual, and data is equals to read. It will all the codes inside the 4 spaces intended block can use f, and the automatic cleanup means as soon as execution exists, the intended block Python automatically closes the final handle behind the scene, even if an unhandled exception or crash occurs inside. Now notice that how Python's core language does not have a built-in function called delete or remove. To delete a file from the hard drive, we must import a standard library module called OS. Full form is operating system. Now this is the example I've written. Now let me break down the code. Here the import OS, which means import operating system, it brings in Python's built-in operating system interface. The if os path.exist means it returns true if the file exists on disk and false if it doesn't. This prevents your script from crashing with a file not found error. And at last, os.remove means it will permanently delete the file from disk. Be careful, it bypasses the computer's recycle bin. Now we have 4 practice problems, real world problems step by step. We'll solve them step by step, and for each problem we'll write the complete code and break down every single line. I can't write the code, but you can. I'll explain the code in the PPT. So our first problem is to create a file named practice.txt containing "Hi everyone, I'm learning Java." Then write a Python program to automatically replace Java with Python. So our step 1 is to create initial file. Now how to create an initial file? This is the syntax. With open practice. We are creating a practice txt file here as f, and f.write. We are inserting the text here. Hi everyone, I'm learning Java in 2026. Our step 2 is to read content into RAM. With open practice.text.r, the R is for the read mode, as f data is equals to f.read. Our third step is to modify the string into memory. New data is equals to data.replace. It is in the third step we are replacing Java from Java to Python. And at last, in the fourth step, we are updating the string back to disk by the write mode. Now with open, it opens practice.txt in write mode, creating the file. It will create the file, and this is the problem we have to solve. It is a easy practice problem. You can solve it by yourself. This is the code you can match. And let's move on to our second problem here, second practice problem. Our second practice problem is to write a function, search word, that searches whether a word exists in the practice file, practice.txt. This is the code. Now let me break down the code. Let's start from the top. Def search word. It defines a function that accepts target word as an input parameter. And on the second line with open, it safely opens practice.txt in read mode. And the third line, it will load file content into string variable data. And next is the if line. If target word in data, it uses Python's in membership operator to check if target word exists as a substring inside data. It is a conditional statement which is used to check if the target word exists as a substring. And at last, print, it displays a formatted message to the user based on the search result. So this is the problem. Let's move on to the third problem. The third problem is to write a function, find line number, that returns the line number where the target word first appears. So this is the code. First, we are defining the function find line number. Now line number 1, here I'm talking about this line number 1. Line number is equals to 1. It initializes a counter variable starting at 1 to track the line index. Second line, for loop for line in f. Here is a pro tip: iterating over a file object f directly using a for loop reads the file line by line effectively without loading the entire file into RAM. Now next, if target word in line. It checks if target word is present in the current single line string. Now return line number. It returns the line number immediately upon finding the first match and exit the function. Here I've added 1 plus 1 in line number. It increments the line number count by 1 before checking the next line. And at last, return -1. This is the standard convention indicating that the item was not found after checking all lines. So this is the third problem. Moving on to the fourth. Our fourth problem, praising and processing numeric data. Our task is to create a file numbers.txt containing 1, 2, 45, 84, 92, 101. Now write a program to read this file, extract all numbers and count how many even numbers exist. So our first step is to create data file. Now this is a syntax with open number.txt. We have created a numbers file, numbers.txt file here, and we are inputting the list 1, 2, 45, 84, 92, 101 by write mode. Our second step is to read data and count even numbers. Are initializing with 0, even count is equals to 0. In this step, we are splitting the text into list of string numbers. In this step, and we are using for loop here, for val in num list, clean num is equals to int val dot strip. It removes spaces and convert to int. It will remove all the spaces, white spaces, and convert to int. And if clean num is divisible by 2, we will add 1 into the even count. We'll increment it, and at last we are printing total even numbers. The output will be 3. Now these are the common mistakes or bugs students do. Mistake number 1 is to forgetting close files when not using with. Fixes always default to with open as if. Mistake 2 is expecting f.read to read twice in a row. Remember, the invisible cursor moves to the end. Third mistake is to opening existing file in W mode by accident. Use A mode to append data safely. I've told you earlier in the PPT. Last mistake number 4, forgetting int conversion when reading numbers. All data read from text file is typed as string. All the text file is typed as string. This is the summary for today's lecture. This is the summary: safe read, line iteration, safe write, safe append, check exists, delete file. This is the summary. You can go through this, and this is the homework and practice assignment. So that completes our chapter number 7, file handling in Python. Now you understand how computer memory works, how to manipulate file paths, how to safely handle reading, writing operations using context manager, and how to praise real world data files. In our next lecture, chapter number 8, we will enter to the world of object oriented programming, which is also called OOPS in short, in Python. Learning classes, objects, inheritance, and polymorphism. Until then, keep practicing. Write out these code examples on your compiler, and I'll see you in the next lecture. Thank you.